Imagine a future where Earth falls silent. It's not a catastrophic asteroid impact or a nuclear winter that seals our planet's fate. This time the culprit is far more insidious, far more fundamental: the gradual depletion of oxygen in our atmosphere. We often take our planet's breathable air for granted. It's easy to forget that this life-giving gas, oxygen, is not a constant. It's a precious resource, meticulously maintained by a delicate balance of natural processes. What if this balance is disrupted? What if the very air we breathe slowly begins to vanish? It's a chilling thought, a scenario that might seem like science fiction. But recent research suggests it could be a stark reality for Earth's distant future. The clock is ticking, and the silent countdown to Earth's next extinction event might have already begun. From the tiniest insect to the largest whale, life on Earth shares a common bond: the need to breathe oxygen. This invisible gas fuels our cells, powers our muscles, and allows us to think, move, and exist. It's the vital ingredient in the intricate tapestry of life. Oxygen is a key player in the process of respiration. During respiration, living organisms take in oxygen and use it to break down sugars, releasing energy to fuel their biological processes. This energy is essential for growth, movement, and all the other functions that characterize living things. Without oxygen, most life on Earth would cease to exist. It's a sobering reminder of just how precious and precarious our planet's atmosphere truly is. In recent years, scientists have observed a disturbing trend. Oxygen levels are declining in oceans and lakes around the world. This phenomenon, known as ocean deoxygenation, poses a significant threat to marine ecosystems. The primary culprit behind this decline is rising water temperatures. As our planet warms due to climate change, the oceans absorb a significant amount of this excess heat. Warmer water holds less dissolved oxygen, leading to a decrease in the overall oxygen content of our oceans. This decline in oxygen has dire consequences for marine life. Fish, invertebrates, and other aquatic organisms rely on dissolved oxygen to survive. As oxygen levels drop, these creatures face the risk of suffocation and habitat loss. The story of oxygen is intricately linked to another gas, carbon dioxide. While often portrayed as a villain in the context of climate change, carbon dioxide is an essential ingredient for life on Earth. It's the lifeblood of photosynthesis, the process by which plants and algae convert sunlight into energy. During photosynthesis, plants and algae use sunlight, water, and carbon dioxide to produce sugars, which they use for energy. As a byproduct of this process, they release oxygen into the atmosphere. This remarkable process is the primary source of the oxygen we breathe. Here's the catch: the efficiency of photosynthesis is influenced by temperature. As temperatures rise due to global warming, the rate of photosynthesis can decline, leading to less carbon dioxide being absorbed and less oxygen being released. Section 5. The Sun's Paradoxical Power, a Blessing and a Curse. The Sun, the giver of life, also holds the key to Earth's eventual demise. While it provides the energy that fuels life on our planet, the Sun's energy output is slowly increasing over time. This gradual increase in solar radiation has a profound impact on Earth's atmosphere. As the planet receives more energy from the Sun, temperatures rise. This in turn accelerates the weathering of rocks, a process that plays a crucial role in regulating Earth's carbon cycle. Weathering is the breakdown of rocks, soils, and minerals through contact with Earth's atmosphere, water, and biological organisms. This breakdown releases nutrients into the environment, but it also consumes carbon dioxide from the atmosphere. Section 6. Earth's Fiery Breath Volcanoes and the Oxygen Depletion Equation. Volcanoes, those awe-inspiring displays of Earth's raw power, also contribute to the oxygen depletion equation, albeit indirectly. While volcanic eruptions release a cocktail of gases into the atmosphere, including carbon dioxide, the primary concern lies in their long-term impact on Earth's carbon cycle. Volcanic eruptions can release massive amounts of carbon dioxide into the atmosphere over geological timescales. This influx of carbon dioxide can overwhelm the planet's natural carbon sinks, like oceans and forests, leading to a net increase in atmospheric carbon dioxide levels. As we've seen, increased carbon dioxide can disrupt the delicate balance of photosynthesis, potentially leading to a decrease in oxygen production and an eventual decline in atmospheric oxygen levels. Section 7. The Great Oxidation Event. A turning point in life's story. To understand the potential consequences of declining oxygen levels, we need to look back at Earth's history. Roughly 2.4 billion years ago, a dramatic event forever altered the course of life on our planet, the Great Oxidation Event. Before this event, Earth's atmosphere contained very little oxygen. However, the emergence of photosynthetic cyanobacteria, tiny organisms capable of producing oxygen through photosynthesis, gradually changed the composition of our atmosphere. Over millions of years, these oxygen-producing organisms released vast amounts of oxygen into the atmosphere, eventually leading to a significant accumulation of this vital gas. This oxygenation of Earth's atmosphere paved the way for the evolution of oxygen-dependent life, including all animals that breathe air. Section 8. Echoes of the Past, Warnings for the Future. The Great Oxidation Event was not without its consequences. The sudden influx of oxygen into the atmosphere proved toxic to many anaerobic organisms, those that thrive in the absence of oxygen. This event led to a mass extinction, wiping out a significant portion of life on Earth at the time. While the future decline of oxygen might not be as rapid or as dramatic as the Great Oxidation Event, it serves as a stark reminder of just how sensitive life on Earth is to changes in atmospheric composition. The gradual decrease in oxygen levels could have profound consequences for ecosystems and the biodiversity they support. The past is not merely a prologue, it's a valuable teacher, offering insights into the potential consequences of our actions and the challenges that lie ahead. Section 9. Humanity's Next Chapter, A Cosmic Perspective. The eventual depletion of Earth's oxygen might seem like a distant threat, but it highlights the finite nature of our planet's resources. It underscores the need for humanity to become a multi-planetary species, capable of surviving beyond the confines of our home planet. The quest for space exploration and colonization is not merely a scientific endeavor, it's an insurance policy for the future of our species. By venturing beyond Earth, we can mitigate the risks associated with relying on a single planet for our survival. Imagine a future where humanity establishes self-sustaining colonies on Mars, the Moon, or even beyond. These outposts of civilization could serve as beacons of hope, ensuring the survival of our species long after Earth's oxygen-rich atmosphere fades away. Section 10. Life Finds a Way, a testament to resilience. While the future might seem bleak, it's important to remember that life is incredibly resilient. Over billions of years, life on Earth has weathered countless challenges, from asteroid impacts to volcanic eruptions to ice ages. Each time, life has found a way to adapt and survive. The eventual decline of oxygen will undoubtedly reshape the biosphere as we know it. However, it's also likely to drive the evolution of new life forms, organisms capable of thriving in low-oxygen environments. Perhaps, in the distant future, Earth will be home to a new generation of extremophiles, creatures that can extract energy from alternative sources and survive in conditions that would be deadly to us. Life, it seems, has a knack for finding a way, even in the face of adversity.